Hello, everyone. Good morning, good afternoon, and good evening. Dear author and invited guest, welcome to a technical session 2A. Myself, Richa, and this session will be moderated by me. On the behalf of the Global Knowledge Research Foundation and the GR Solistic LLP, it's my great pleasure to welcome you to the 9th International World Conference on Smart Trends and System Security and Sustainability, WS4 2025, London, UK. The ninth edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in London, UK, and the virtual event is being held through Zoom today and tomorrow. I hope you will enjoy the knowledgeful and interactive session through the day. In this session, we have 6 presentations. Each presentation will be given 12 minutes for presentation and 3 minutes for question answer. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants. There you will all stay connected with us through the closing remarks. If you have any query and any update, write it to me in a chat box. Just before we get started, I would like to introduce you to all our chair of this session. Now I would like to invite Professor Kunisku Takamatsu is a professor of Institute Management in the Office of Strategy and Planning at the Tokyo Institute of Technology, Japan. His main work focus on institutional research in the university and university reform in a higher education through edu-informatics. Welcome to you, sir.
You invite me this session.
And further, we have another session chair, Dr. Anubha Jain. Dr. Anubha Jain is working as a director in School of Computer Science and IT IS deemed to be University, Jaipur, India, and academician for the year of 23 years. She has actively contributed in a teaching industry and R&D. Her research interests include soft computing, computational studies, IoT, and software engineering. She is the author of 9 books and published a number of papers as a national as well as international levels. Welcome to you, ma'am. And now moving further, I would like to invite our first presenter to present her paper on a non-intensive approach to structural damage detection in a civil engineering unveiled through proper ontological decomposition POD techniques. Dear presenter.
Hello everyone. Good morning all. Okay. So can I start now?
Yes, please.
Okay. Can you guys see my screen?
Yeah, it's okay.
Oh, okay. My name is Srimali Gunasekara.
Oh, wait a second. I actually see the so I'm not sure that is a presentation that you
Your presentation slide is not visible.
Oh, okay. That okay now?
Yes, now it's
Yep.
Okay, thank you. First of all, thank you so much for this opportunity. Today I'm going to present one of my undergraduate research project. The topic of my project is an uninvasive approach to structural damage detections in civil engineering unveiled through proper orthogonal decomposition POD technique. Okay. Next. This is the outline of this research. Introduction about damage structures and existing methodologies. And next, explain the research problem. After that, the objective of this research and methodology that we used in this research, and also results and discussions. And finally, conclusions of this research. Okay. All of us know the stability of civil engineering structures is very important in the real life. It is affected all day-to-day work. When the structures have weakness, then their capacity gradually decreases. That's the one of major disadvantage of the damaged structure. You can see there are several damaged structures such as bridge, wind turbine, aeroplane, and also buildings. There are many reasons for these damages, such as crack, use low quality materials, poor workmen, poor designs, etc. Therefore, early damage detection is very critical to economy, public safety in all over the country. So let's see how to detection the damage of the structures. So the first step is detections of damage, and next localization, which is to identify where is the damage. Next step is assessment of damage severity, and final step is predictions of remaining service life. Using this cycle, there are several damage detection methods in the literature. So let's see, these are the several damage detection methods in the literature. Okay, we have two categories of damage detection methods, such as local damage detection methods and global damage detection methods. Local damage detection methods can only be applied for portions of simple and complex structures. For example, as shown here, ultrasonic inspection and magnetic particle inspection methods are local damage detection methods. So the first one, ultrasonic method, is very fast method, and that can be used for metal, liquids, and many other materials. As you can see in the figure 6, when the surface is damaging, amplitude is reduced. Next, magnetic particle inspection. First, put the magnetic particle field into cracked part and identify the damage inspection. Damage using the directions of the magnetic field and identify the where is that damage. So these methods can used only for metal surfaces as iron, nickel, and also cobalt. So these are the local damage detection methods. Because previous methods are very difficult to apply for a global structures, there are several global damage identify methods as vibration-based damage detection methods, eigenfrequency methods, and also curvature method. In vibration-based method, check the characteristic of the structure as stiffness, mass, or energy. If those are changed, they can identify the damage using the sensors as shown in this figure. And the eigenfrequency is very sensitive for the damage. Here, according to the difference of eigenfrequency, can be identified the damage and also where is the damage. Curvature methods also uses the change of curvature to identify the locations of the damage. So those are the damage detection methods in the literature and also in the practically they are using. So now move to our problem. As I mentioned earlier, bridges are very important structure for the transportation. Therefore, in this research, we are going to propose a non-invasive methods to identify the damage of the bridge structures. So actually, I was extending the research problem with this experiment, which has done by my supervisor, Amila Sudhuambagedra, on his PhD in USA. I used those data for my research. And also Matthew have done these data collections using the Waddington Bridge in New York, which is in showing figure 9. Okay, used for the experiment for this research. You can see this bridge consists of concrete slab and supported by 3 interior and exterior girders. They have divided this bridge into 3 sections. And also there is a truck which contains the vibration sensors goes through all 3 sections. And also in here under this bridge, attached 30 accelerometers down the vertical and horizontal directions to measure the acceleration. And here there is first diaphragm connections have been located between the 3rd, 4th, 9th, 10th, and also 15th, 16th, such as accelerometer. And the next one is they are using wireless sensor with vibration-based methods, as I described earlier, to identify the damage with 120 Hz. Okay. So now next one. So these are the accelerometers which will identify the accelerations. You can see here accelerometer under the bridge to measure the accelerations. Actually, figure 13 is shown the balls connections of the first diaphragm. Here, there are 6 balls on the first diaphragm, and they introduce 3 scenarios. First one is healthy structure, and other 2 scenarios are damaged structures. Here, damaged structure introduce removing these balls. I will explain that later. And this is the truck has been driven through this bridge to measure the vibrations in each scenario. And these are the scenarios used for healthy and damaged structures. The baseline is the scenario 1, that is called an healthy structure. Scenario 2 is damage 1. In this scenario, remove 4 out of 6 balls from the first diaphragm. Damage 2 created by removing 6 out of 6 balls from the diaphragm. They test 3 times for each scenario, and each test consists approximately 90 seconds. That means the truck takes 90 seconds to drive from one side to other side on the bridge. That's the method they use to collect data. So the objective of our research is, first we consider that data set and generate basis functions using proportional decomposition method. Next, do the order reduction, identify the dynamical modes with damage. After that, using eigenvalues and eigenfunctions, I'm predicting the damage to structure. So I used previous acceleration data, set up third pass of the truck of the baseline and damage 1 scenario as the training data set. After that, we predict the damage to acceleration data using that baseline and damage 1 scenario using the proportional decomposition method. Okay, next, I will quickly explain what is the proportional decomposition methods that we used in this research. That's the multidimensional statistical method to get the compact representation of the data. The main purpose of this method is reducing the order from the higher dimensional data to a lower dimensional data. If data set U which has n dimension, next we are finding the correlation matrix, which is n by n matrix using transpose of U and multiply by U. Next, determine eigenmatrix, which is n by eigenvalues and eigen matrix correspond to the eigenvalue. Eigenvalues are getting largest to smallest, then we can identify the most dynamic basis functions for our research. After getting most important eigenmatrix, we are reconstructing the original matrix using inverse of eigenvector matrix. We can also use the transpose of the matrix instead of inverse matrix because they are orthogonal. And finally, here we are comparing our results using a statistical method based on the kurtosis. So let's go through the results. So this is the eigenspectrum. As I discussed previously, first find the eigenvalue by using our data matrix. And I obtain these eigenvalues using the accelerations in the vertical and lateral directions of baseline and damage 1 dataset after the third pass of the track. Here we are getting total 120 eigenvalues, but you can see after the first 40 eigenvalues, those are going to 0 and we can negligible those eigenvalues. Therefore, we are using first 40 eigenvalues instead of 120 for the finite representation of the acceleration data. Now here we are reducing our dimensional from high dimensional to low dimensional. So previously we discussed we are predicting damage to accelerometers data. Actually here we are using these only 40 eigenvalues and its eigenvector matrix to predict the damage to acceleration data. Okay, these two plots are shown the produced accelerations and original accelerations of damage to. First graph is for the 10th accelerometer, which is very near to the first diaphragm. And the second graph for the 14th accelerometer, which is very far away from the first diaphragm. You can see the norm or error of and original accelerations in the first figure is smaller than the second one. Therefore, we can use proportional decomposition method to predict the accelerations of damage 2 using the training data set. And the next one, in here we are comparing predicted damage 2 data with baseline healthy structure data. You can see the variance between two scenarios of the first graph is larger than the variance of the second graph because the first graph occurred into the accelerometer, which is near first data. So we can identify what is the damage location also using this result. And finally, we are going to compare previous results with courtesies of accelerometers because courtesies give us insight into a shape of data set beyond just the average of spread. Here, courtesies of near accelerometers is higher than courtesies of accelerometers which are far away from the first diaphragm. For example, highest relative change is 10 and 15th accelerometer which are near the first diaphragm. And second and 14th have very small relative error of the baseline and damage 2 results because those are in very far away from the first diaphragm. Therefore, we can identify again damage locations using kurtosis. So before end of my presentation, the conclusions of this presentation is we develop an invasive damage detection methods using proportional decomposition method, and also we can find unstable locations of the bridge by using this method. And yeah, this method is good for the other real world problems with other civil engineering structures, maybe buildings or other damaged structures. And these are the references that I used for our research. And thank you very much.
Thank you very much. Also, do you have any questions for participants? No? So I have one or two questions. Usually, thank you very much for your good presentation. I think your result is very good. And usually you said the POD method is a very good method to predict the check of the bridge or something. And I have the question. Did you perform any other dimension reduction method? Did you try already? No, just only one. The POD?
No, I didn't
No.
try. I just
Mhm.
tried POD and I confirm those results are correct with statistical method thoughts.
So if you write submit the journal, so it is good to compare the other method with the POD method, I think.
Okay.
Mm.
Yeah. Thank you so
And
much.
okay, and any other questions? No? Okay, thank you very much. I have finished my question.
Thank you so much.
Thank you so much, dear presenter, for your presentation. Now I would like to move forward to our next presenter. Next presentation is on a sightseeing planning support system specialized in sports tourism. A paper presenter is Rayushu Nobita.
Thank you for chairperson to introduce. I will share the screen. So, please wait a moment. Now I'd like to start the presentation, and it is a great honor to be here to present my research I'm Ryu Nobeta from the University of Electrical Communication in Japan. Today, I'd like to talk on a sightseeing planning support system specialized in sports tourism. And this is the outline of my presentation. And first, introduction. In recent years, the purpose of tourism has become diverse, and one of them is sports tourism, which combines sports and travel. And in particular, sports spectators visit cities where other teams are based to watch the game and tour the surrounding areas. However, it is difficult for tourists who are unfamiliar with the cities to make tourist plans considering the game time. Therefore, this study aims to develop a tourism planning support system for sports spectators to make effective use of their time before and after the game. And this will lead to promote the revitalization through sports tourism. And next is related works. This study is related to following three study fields: the research on sports tourism, and research on tourism support system, and research on information sharings. And in comparison with the preceding studies, the present study has three original features. The first, tourism planning can be made by looking at the digital map. And second is promoting sport tourism by displaying user ranking for sports. And third is available to sports spectators as well as local people. And this is a research framework. First, we design and develop the system. After that, we conduct an operation. Then, we conduct a questionnaire survey and access log analysis to evaluate the system. Next is the system design. This system is designed from WebGIS and Tourism Planning System, SNS. The WebGIS digital map displays and registers spot information. The tourism planning system is used to set up spectator game and select sightseeing spot. The SNS enables users to post spectator records and show the user ranking. The system effectiveness is these 3 points. First, users can obtain tourist information on sports. And second, it is available to people who are unfamiliar with the cities. And third, local people can share little known spot and other local attractions. And this is the system development. In the front end of the system, these functions are implemented. And users can use these functions by PCs or portable devices. I explain making tourism plan function. It is intended to support sports spectators. And first, users enter the date and time of the game. And then users select the visiting spot from the GIS digital map and enter the time. By repeating this process, a plan can be made. And next, I explain registering new sightseeing spot function. First, to post a new spot, click the digital map and determine the location of the spot. Once the location is determined, a pop-up window will appear and enter information about the spot. Spreading new spot like this will lead to more revitalization. And this is spectator record posting function. First, users can share their spectator record by entering comments and select photo and post them. Other users can also rate these posts by clicking like button. And I explain show ranking function. The ranking is based on the number of visits to sightseeing spot related to sports and the number of posts about spectator records. With score increasing accordingly, user IDs are displayed in order to highest scores. The operation target area of the system is Kawasaki City in Kanagawa Prefecture. There are two main reasons. First, Kawasaki City has many sports teams and frequently sporting events. And second, it is easy to access to stadium and sightseeing spot because it located next to Tokyo. This is an overview of the operation. We conduct the operation for about 4 weeks, and after end of the operation, we conduct a web questionnaire survey and access log analysis to evaluate the system. The system is used by 63 people, and the respondents to the questionnaire were 50 people. From the survey respondents, a wide range of people answered. The following are the result of the evaluation based on a questionnaire survey. In response to the question, do you think this system is useful for collecting sports information? 93% of respondents gave a positive answer. Therefore, the system effectiveness one that users can obtain tourist information on sports was confirmed. And next, in response to the question, was it easy to locate each attraction on the digital map? The 96% of respondents gave positive answer. Therefore, the system effectiveness tool that is available to people who are unfamiliar with the states are confirmed. And next, in response to the question, was it easy to operate the registration of a new sightseeing spot to lead to regional revitalization? 81% of respondents gave a positive answer. Therefore, the system effectiveness theory that is local people can share the local attraction was confirmed. And finally, in response to the question, do you think this system makes it easy to make a tourism plan to watch sports? 90% of respondents gave positive answer. Therefore, the purpose of this study that develop a sport tourism planning support system was achieved. And in addition, we use Google Analytics to analyze the user's access log. From the result of the device accessed, the main access method was mobile phones, and there were also many access from PCs. And from the result of the number of visits by page, the top page and tourism planning page were frequently used. This indicated that the system was used by the intention of this study, which is for users to support making tourism plan. In conclusion, We designed and developed by integrating WebGIS planning system and SNS in order to support sports spectators in making tourism plan. Then we conduct the operation for about 4 weeks in Kawasaki City. The result of the operation and evaluation shows that the system is effective in supporting making tourism plans for sports spectators and effective in promoting local attraction by local people. Finally, future research topics. In terms of system function, we have 3 points. We will improve each function and web page design to enhance system operability, and we will provide opportunities for users to interact with each other. And we will support for tourism planning as well as tourism behavior. And in terms of system operation, we will operate in other cities to increase the significance of its use. This is references. Thank you for listening to my presentation. Thank you.
Thank you very much. Good to your presentation. So participants, do you have any questions? So I have one question. So I was surprised because now I'm located in Okayama Station, so very near the Musashi-Kosugi Station. So I'm very happy to meet you in this international conference. And I have a question. In your advertisement for the to take part in this experiment, the in Kawasaki City's official homepage provides the URL. Is it right?
No, I advertised and I went to the stadium and I promote the sports spectators in there and or I advertise and my homepage research homepage.
Okay, thank you very much. And do you know the ratio of the Japanese people or the foreigner for the questionnaire? Do you know?
Yes. The questionnaire is only Japanese, but
Japanese. Okay, thank you very
yes.
much. Thank you for your presentation.
Thank you very much.
I would like to call Anubha ma'am. Ma'am, any question regarding the previous presentation?
Thank you, Richa. No questions from my side. Thank you.
Okay, thank you, ma'am. Now moving ahead, I would like to call our next presenter. To present his paper on a system utilizing landmarks to support users' new discoveries, a paper presenter is Taiki Katsuragi. Dear presenter, are you in meeting? Any co-author of this paper?
Thank you for chairperson. I am Taiki Katsuragi from Economics University. I will give a presentation.
Oh.
title, a system utilises landmarks to support users' new discoveries.
You may please start your presentation.
Oh. Um, oh. Can I start presentation?
Now, we see your slide. So go ahead.
Okay. Okay, today's outline is that. First, I explain the background and purpose of the study. It is the interest in discovering new things in regional community is developed. There, it is important to make people aware of things they are not. For this purpose, highly visual landmarks are useful. For example, convenience store, gas stand, and station. This research aims to create a system that utilizes highly visual landmarks. In addition, that makes users aware of various things in the real world. There are framework of this research. First, we designed and built the system. Next, put it through operation and conduct questionnaire survey and access log analysis. Finally, we evaluated the system. That is the design of the system. This system uses WebGIS Web Geographic Information System. That includes some function. For example, displays some landmarks and record visited landmarks. In addition, there are functions that called mission. That is, use game method and it serves to encourage the use of system. There are effectiveness of the system. First, that is encourage new discovery. It asks users to look around the landscapes and search for the landmarks. Next is that system promotes users to use system by video game methods. Utilize video game method in other system is motivate users. That technique is called gamification, and that method used with in systems. Finally, users can search, spot, and find new discovery in real world. In the process, new discovery may be system will be used in much situation. Therefore, this system can be used with mobile phone and PCs. Next is front end of the system. Users can use many functions. For example, view spot on the map, record spots users have visited, created new spots, record favorite spots, and give mission and get score. Show you how to use some of function. First, that is the appear spot and visit spot function. The location of the spot are displayed on digital map, and users can their register spot they have visited. When they visit the spot, users push that visit button, and spot name and information is appear on the spot on the map. To see information about the spot, users need to visit it. This system gives them a reason to actually workaround. On the next slide, you see how to create a spot. You can create many spots anywhere on the map. You can use it to share your discovery with other users. When you create new spots, you push some place on the map and enter some information, for example, spot names, spot detail information, and picture. You can create new spot appear, and that is appeared. That is mission function. Users are given a mission, for example, visit 1 spot, create 3 spots, and log in 5 days. By using the system according to a mission instruction, you can explore the area. When they clear a mission, push the reward button and they can receive a score. That score collected in the mission are displayed here. You can see how your score compares to other users. This feature increases your motivation to use system. There is an area to be covered by the operation. The area of operation is Chofu City in Tokyo. The city has many tourism resorts. For example, Shindaiji, the famous temple. This may be interest for users and attract them. In addition, the city encourages visitors to walk around the area. Operating system in such area is effective. The target population is teenager and older. They were both in and outside the target area. The operation lasted 43 days. Evaluation method is questionnaire survey and access log analysis. Question of survey focus 3 evaluation items. The evaluation item was usage of system, function of the system, and effectiveness of the system. Here is an overview of survey. Out of 73 users, valid respondents are 50, and the valid respondents rate is 64.9. In the respondents, 68% were male and 32% were female. The system has been used by a wide range of users from their teens to their 70s. Moving on the next slide. The evaluate is based on the result of questionnaire survey. First, we asked the question, did you discover something in the place of finding a spot? 84% respondents gave a positive response. That indicated the system promoted new discovery about the region. Next is the question, did the mission motivate to use the system? 76 respondents gave a favorable response, and the point game method could promote users to utilize the system was shown. Next is the result of question about real-life view. For the question, was it exciting to find spot in the real world? 86% respondents gave a good response. For another question, have you become aware of places that you are not normally aware of? And 92% of respondents gave a positive response. Thus, we can show the effectiveness of finding spots in the real world was beneficial. That is evaluation of system based on survey. That is about free description about the system. First, some users confused because there are so many types of spots. So limit the type of spots. Next, there were some requests for restaurant spots. So we collected information by some service and adding such spot information. The system is then evaluated based on access log analysis. This rank a number of visits to each page of system. The map page was most visited because it was most basic function. This means that system was used an integers. The explanation function will be used repeatedly when logging in for the first time. Conclusion this presentation. First, we created a system to support new discovery in the committee of area. We also use highly visually landmarks to create it look at real world. The system operated for about 40 days in Chofu. Teen and older were targeted, and we evaluated the system by questionnaire survey and log analysis. As a result, we found that point first, the system promoted new discovery about the region. Second, that used real-world effective. System that promoted new discovery in the real world was developed. Finally, I will describe our plans for the future. First, we will address the system issue. We need to re-examine the sport we handle. We are also considering applying the area of operation. The value of system will increase if it can be used in various of locations. There are reference and the source of photo. Thank you.
Thank you very much. Good presentation. I have one or two questions. The participants is all Japanese. Is it right?
Oh.
So because your system is very useful for the foreigners, I think, because foreigner it is difficult to find out the sightseeing spot. So especially the deep, how can I say the deep spot. So in this case, your system is very useful, I think. So my question is, the participants of the questionnaire is all Japanese.
And that system
This case
was all Japanese.
all Japanese. Okay.
All Japanese, but I think that system is useful for foreign people. Some of users are English speaker and they use the system with transfer service, but they evaluate that system so it is beneficial to develop that system not only Japanese but also English and other language.
I think so. Thank you very much.
Thank you, dear presenter, for presentation. Ma'am, any question?
Yeah, it's a very interesting topic. So I just want to know that are you just focusing it for Japanese, and what is the difference between this and what we do on Google? How is your system different from Google Maps?
Google, that system is that difference of with Google Map is higher visual higher visual landmark. Google Map Google Map shows many spots so that is not so user look smartphone or some tablets with work and they cannot see the real world view, but that system show only a higher visually landmark. So the information is limited. So users must have to see real words. That is
Okay, I got it. So another question is, now in your future research, you are going to let the users add spots to it, right? In your
spot.
future work, you are
Okay.
allowing the user to add new spots in your maps. Am I
Yes.
correct? Now that won't that be a little challenging for you? How will you justify, or how will you basically check whether they are adding correct spots or not? Is
Oh,
there any way to authenticate that spot? So that is something you should take care while adding the new spots. When you'll start working on that,
the,
in your go on your future work slide.
oh, yes. Spot will be edited. Like,
Taiki, did you get it? Did you get my suggestion?
of,
While when you are adding new spots in the map, if you are allowing any user to add new spots, then there should be some mechanism to authenticate whether that spot actually exists or not. Right?
spot.
That is it from my side. Thank you.
Oh, thank you.
Thank
Richa,
you,
am I
dear presenter.
audible?
Yes,
Yeah.
ma'am, it's audible. Thank you so much for your presentation. Now moving ahead to our next presentation. Our next presenter is present her paper on classical and quantum cryptanalytics attack on block chippers. And paper presenter is Hypely Thi. Dear presenter, are you in meeting? Any co-author of this paper? Okay, moving forward to our next presenter. A paper presentation on optimizing of coverage and energy efficiency in a wireless sensor network, a hybrid WO language techniques. A paper presenter is Momer Usmani BA. Dear presenter, you may please start your presentation.
Hello, good morning, everyone. Today, I am pleased to present our work entitled Coverage and Energy Efficiency Optimization in Wireless Sensor Networks. In wireless sensor network using a hybrid WOA GA AI approach This research was carried out at Iba Der Thiam University in Senegal. I will structure my talk into 9 parts. 1, introduction. 2, our objectives. 3, state of the art. 4, our hybrid WOA-GA-AI algorithm. 5, experimental setup. 6, results. 7, computational cost analysis. 5, discussions. 9, and finally, conclusion and future work. Wireless sensor networks, or WSN, are essential for applications such as environmental monitoring and healthcare. Their main limitation is energy management because not use non-replaceable batteries. Our goal is to optimize both their lifetime and their energy efficiency. We have 3 main objectives. 1, minimize energy consumptions to extend network lifetime. 2, maintain connectivity despite not failures. 3, propose a hybrid WOA-GA-AI algorithm for optimal resource allocation. State of the art. Classical algorithm like PSO, ACO, or GA have limitations such as suboptimal energy management and low adaptability. Our innovation is to integrate AI using multi-agent Q-learning to enable dynamic decision-making. We also use K-mean clustering for smart initialization. Our algorithm combines WOA for efficient exploration of the solution space, inspired by whale behavior, GA for strong genetic operations, and AI specifically Q-learning for adaptability. We also include smart initialization and cooperative learning between nodes. This diagram summarizes our approach. We start by initializing the whale with K-mean and assigning each whale a Q-table. At each iteration, we update parameters and measure solution diversity. If diversity is high, the whale performs a WOA movement, spiral, or local exploration. Otherwise, it performs a targeted attack. Sometimes GA operations such as crossover and mutation are applied to introduce new solutions. Then Q-learning takes over. Each whale observes its state, select an action, receive a reward based on coverage and energy, and update its Q-table. We record performance, adjust in case of stagnation, and stop when diversity is too low or results stop improving, returning the best energy coverage solutions. We simulated a network of 100 nodes over a 100 by 100 meter area using AMNET and Castalia. K parameters include an initial energy of 0.1 joule per node and packet of 1000 birds. Fitness coefficient P1 equals 0.7 and P2 equals 0.3. Here we show the comparison of different algorithms in terms of network lifetimes. For example, WOA-GA-AI reaches 950 iterations before the last node dies, compared to 505 for GA. That's an 88% improvement. This slide shows the residual energy of different algorithms over iteration. Notice that at iteration 500, WOA GA-AI keep 7 joule while GA is close to 0. This slide shows the amount of data transmitted to the sink by the algorithms over iteration. Here too, our algorithm maintains 15 kilobits until iteration 900, whereas GA stopped at 500. Computational cost analysis. Our algorithm is 15 to 20% more expensive per iteration than GA. However, it reduces the total number of iterations by 25% thanks to faster convergence. This trade-off is worth it as we achieve 15% network lifetime and 19% more data transmitted. Discussions. Our approach outperforms PSO, ACO, and GA in lifetime, residual energy, and data volume. The gain comes from the synergy of the three components. WOA ensures efficient global exploration. GA increases diversity and avoid local minima. Q-learning dynamically adapts action for fine energy management. The algorithm has a higher computational cost, but it is offset by faster convergence and better overall performance. A limitation is that we test it in a static control environment without radio interference or node mobility. In conclusion, WOA-GA-AI significantly improve all key indicators. 15% longer network lifetime, 19% more data transmitted, and 10% more residual energy. This confirms the value of combining WOA, GA, and AI in a single multi-objective optimization frameworks. Future works includes 1. Testing in dynamic network with mobility and interference. 2. Reducing computational costs with parallel or distributed versions. 3. Comparing with newer methods like GWO, SMI, or HHO. 4. Integrating energy harvesting mechanisms. Overall, this work lays the foundation for smarter and more adaptive WSN optimization. Thank you all for your attention.
Thank you for your presentation. So unfortunately, I cannot understand in detail of the WOA GA approach. So my question, I have no question. The Professor Professor Jane, do you have any questions?
Yeah, thank you. Thank you, Professor Takamasu. Yeah. Am I audible? Richa, am I audible?
Hello. No, ma'am.
Just 1 minute.
Yeah.
Connect from my phone then. Now am I audible, Richa? Richa, is it audible now?
Yes, ma'am. It's audible now.
Yeah. Okay. So I have a question for you. Did you apply Hello?
Hello.
Yeah. You have applied genetic algorithm, right?
Can you repeat your question?
Just tell me the full form of your hybrid approach. WOAGA. Am I audible to him or not?
I don't understand the question. I'm more comfortable speaking.
Can you
I'm
go
comfortable.
on your flowchart slide? Can you please take your presentation on the flowchart slide?
What
Flowchart.
slide? Flowchart.
Flowchart.
Yes.
Flowchart.
Flowchart, yes.
Okay. So the you have applied GA, right? Mumar, you have applied genetic algorithm on your WA network, isn't it?
Can you repeat your questions?
Did you apply genetic algorithm out here? Genetic algorithm.
Wait, when I make crossover. Here we
How
use
is crossover helping you out? How is crossover helping you out here?
crossover to crossover to for mutation. We have a nouvelle individu. When we take crossover, we have a new population.
Right. So what is the advantage that you are getting from this?
Can you repeat slowly?
Yeah. What is the advantage of doing crossover in this algorithm? Any advantage you got from doing crossover?
Crossover is used for GA operations. This
Okay.
is
Thank
clear.
you.
Crossover GA operations.
Okay, thank you.
Thank you.
Thank you so much, presenter, for your presentation. Now moving ahead to our next presentation. Our next presentation on optimizing early detection on a plant disease, a web application using mobile net as a CNN network. And paper presenter is Smile Zabri.
Yeah, okay. Do you see my screen? It's good. Okay. So good morning, everyone. My name is Ismail Jabri. Today, I will present our work titled Optimizing Early Detection of Plant Diseases, a web application using MobileNet as CNN network. This research was conducted with my colleagues at Sidi Mohammed bin Abdullah University in Morocco. So the main motivation and the problem in our research is that plant diseases are a global threat, causing up to 40% of crop losses each year. And the traditional diagnostic methods, while maybe they are accurate, they are very, very expensive and time consuming, and not all time accessible to the small holder farmers. So we asked ourselves, how can we make disease detection fast and accurate and accessible? So as you can see here, the old challenges in the traditional diagnostic methods are accessibility limitations, time resource constraints.
10 minutes. Bon, 12 minutes, 10 minutes
Okay.
laa def.
And sensitivity specific issues. All right. So the main objectives or contributions that we made are threefold. First, it was building a real-world data set of 26 species and 54 diseases. So we not only augmented the normal data set, but we accurated that data set to make it more diverse. So the second thing is fine-tuning a mobile net version 2 into achieving 97.4 accuracy with only 3.5 million parameters. And the third one is deploying this model in a user-friendly web application for real-time diagnosis. So related work. When we started doing our research, we came to ask ourselves, how can we achieve what we want? So previous work achieved impressive accuracies, often above 95%. However, most studies relied on lab datasets with clean backgrounds, limiting the real-world performance. And heavy models like ResNet or Inception were also impractical for mobile use. However, in 2017, when the MobileNet offered a lightweight alternative with high accuracy, it was the main choice for us to adapt our model. So here is the main model architecture. So at first, we accurated a data set of 30 gigabytes, including field images from Tanzania, and we web scraped data to reflect real-world conditions, variations in light, background, and noises, to ensure that our data set is as much as possible as realistic. This ensured our model to learn from realistic challenges farmers face every day. So once we got the data set, we did some image pre-processing, resizing the images, normalizing, label encoding, and data augmentation using rotation, flipping, and zooming. Then we put all of this into training our fine-tuned mobile net. So if you zoom our net, it has a lot of layers. Basically, it has the base layer, then the global average pooling layer, then the dense layer, the dropout, and the final softmax function that give us the classification if the plant is going to have is having a disease or not. And we put our final model into a web app application that we integrated in a web browser. So here is some experimental results. As you can see, the MobileNet model learned very quickly and very well from our very diverse data set. And as you can see, the MobileNet version 2 achieved competitive results compared to heavier models like ResNet, DCNN, while requiring fewer parameters and faster conversions. Importantly, on field tests from Tanzania, the accuracy remained above 97%, proving that our model not only performed well in real life, but also actually it was very fast and lightweight, so that you can even like scan it into the real world. So here is our web application that we developed. So basically, the user, all he has to do is to select the plant, then scan it, and once the user scan the plant, he will get if, for example, the plant has a disease or not, etc. So to make this model accessible, we built this Flask-based web application. Users, all they have to do is upload a leaf image, and within 0.2 seconds, they will receive the predicted disease and the treatment suggested. So this bridges AI research with practical field applications. As you can see, here is the result, for example. This is the name of the disease, and this is how the user what might he do to fix these diseases. So in conclusion, early disease detection system not only bridged the crop losses. So since it had three main parts, which is the MobileNet, the real data set that we created, and the web interface. So this bridged into a scalable tool that can be used into a real world use cases, where farmers, all they have to do is scan and get what they want. So this is all. Thank you for your attention, and thank you for your, if you have any questions, I'm available. Thank you.
Well, thank you very much, your good presentation. I have only a short one question. The web type is very convenient and easy, but do you have any plans to develop the application for the smartphone, or for example, the Android or iPhone?
Yes. Actually, we are planning to develop a web application, a mobile application that is using Kotlin or even Swift for iOS, so that our application would be both available in Android and iOS mobile phones. And we will use the same logic, and we will implement all of this into that Android application. Yeah, it's mainly in the future work. Yes, definitely.
Great, thank you.
Thank you.
Yeah, it's a very, very interesting and useful app, Ismail.
Thank you.
So tell me one thing, how many plants are you catering to?
So right now we have 26, if I'm not if I'm right, and 54 diseases. So we have 26 plants types and
Okay.
54 diseases types in total.
Okay.
Yeah.
Okay, and you have given
So
a
it's
comparison with ResNet, LXNet, and RCNN. Again, RCNN is almost as comparable as MobileNet in your case, as I could see from the table.
Yes, yes. However,
So,
the problem you do that with the normal CNN is that it's heavier than a mobile net. Mobile net is very lightweight, so we can easily implement it into a phone in the future, or and it can be very fast actually, since it gives us almost the same results or have very good accuracies in that. And that's what we want, something that is both fast and lightweight, so that it can be even installed in edge computers or mobile phones, for example.
Okay, thank you.
Thank you.
thank you so much, presenter, for your presentation. And moving ahead to our last presentation, a paper presentation on quantum algorithm of partial differential equations, a performance review and future trajectories. And paper presenter is Thang Nuchian.
Okay, can you hear me?
Yes.
Okay, I will start my presentation right now. So, good morning, everyone. Today, I'll be discussing the exciting intersection of quantum computing and partial differential equations. So, drawing from my recent work, our goal is to explore how quantum algorithm can be used in the way so that we can solve complex physical system modeled by PDEs. So as we know it, PD are the backbone of science and engineering, describe pretty much everything from fluid dynamics to more complicated things like quantum field or even financial and business. So on the other hand, solving them is computationally very intensive. Traditional numerical method often face a curse of dimensionality, whereas the computational costs explode with the increasing complexity. They also struggle when the equations are partially unknown, or let's say data is sparse or noisy due to manual records. This bottleneck is often prevent us from achieving the high resolution simulation for cutting edge research and industrial applications. Uh, the solution to this noisy PDE is can be quantum computing by harnessing the principle like superposition or entanglement. They can promise the, the good enough performance with unprecedented efficiency. This has naturally led to the development of quantum algorithm designed for PDEs, aspiring the achievement breakthrough beyond the classical capabilities. Uh, I categorize these into two main strategies: quantum linear system solver and variational quantum algorithms. For the near term, hybrid quantum classical approaches are particularly promising, allow us to use the currently noisy quantum hardware, crucially the very nature of quantum mechanics, with the wave-like representation intuitively aligns with the mathematically of the many physical PDEs. So one of the primary quantum strategies for PDE is converting them into linear system of equations, a common step in classical numerical methods. At the heart of it, a quantum approach, where we have the HHL algorithm. Um, it was groundbreaking at the time, promising the exponential speedup with its dependent on problem size. The core idea is to encode the solution vector into a quantum state and inverting the matrix on the quantum computer. This is achieved by using a quantum phase estimation to extract the eigenvalues, performing a control rotation based on the inverse, and then reverse the phase estimation. However, it is crucial to acknowledge one weakness of HHL is that it heavily relies on sparse and well-conditioned matrix. It's also provide statistical access to solution. And what another weakness of it is it requires a full-blown mature hardware which have no noise at all. And okay. In the contrast to the fault-tolerant requirement of the HHL, we have variational quantum algorithms or VQAs. It offers more immediate path for current noisy devices. VQA are inherently hybrid. A quantum computer prepares a parameterized quantum state, often called the ansatz. As you can see in here, it is a quantum circuit representing the ansatz and the model. And it will produce a result to evaluate a cost function. This cost function quantify how well the quantum state approximate the PDE solution. A classical computer and that can then use this information to iteratively compute the parameter for the quantum circuit, seeking to minimize the cost here and thus roll back to the global minimum, hopefully. For example, VQLS address a linear system by minimizing the cost function that measures the deviation from the desired solution. The beauty of VQA lies in the adaptability to the limited coherence and noisy nature of the quantum hardware, making them a leading candidate for early quantum advantage for PD applications. Now, a little bit zoom in a specific and highly promising VQA, the quantum approximate optimization algorithm, or QAOA. Originally, it introduced as a approximate combinational optimization. QAOA operate by repeatedly applying two quantum operation. The first one encoding the cos Hamiltonian, and it is our specific problem to be encoded in this block, and then the mixer Hamiltonian, which helps us to explore possible solution for the cos blocks. It will be repeatedly applied to each other. There can be many more longer. So while QAOA is fundamentally an optimization algorithm, its principle can be applied to PDE by framing parts of the PDE solution process as a optimization problem in this block. One common way to approach PDEs is first discretize them into system of linear equation using method like FTM. The linear system needs to be solved by QAOA. QAOA can be integrated into broader framework for solving PDE, especially when the optimization techniques can be leveraged. Instead of directly solving the PDE, QAOA is used to enhance the component of another PDE solving method, particularly in addressing computationally intensive subproblems. We actually have a demonstration for solving with another VQA. For our demonstration implementation, we use the underdamped harmonic oscillation problem, a classic in physics, describing the movement of oscillator under the influence of restorative force and frictions. The physics of this system is precisely captured by this PDE over here. To enable our quantum model to infer natural physics, we employ an ensemble cost function. This cost function is designed to combine the data loss term in blue with the physics loss term with the green. This physics informed term is ensure that our model prediction is comply with the established physical laws. We further used two hyperparameter to balance the contribution of these two terms, which are indicated in the pink highlight. It will guide the model to learn from the both data and underlying physics. To test our approach, we set up an experiment comparing three models. First is the PIQML 109, which is a quantum model of 109 parameter gates. The second PIML 113 is another classical multiple layer perception network designed with a parameter count 113, very similar, very closely to to our quantum model. And thirdly, the physics-informed machine learning model of 2,209 parameters, very larger, serve as a more robust classical benchmark. We train these model onto different datasets of harmonic oscillation. These datasets were synthetically generated with Gaussian noise to realistically simulate the potential measurement errors. And importantly, the quantity of the data points was intentionally limited to mimic the condition where the data collecting is challenging in real-world scenarios. The core task for our model was not only to infer PDE describing the underdamped harmonic oscillation, but also accurately estimate the unknown coefficient of friction, the mu. This mu. All models were optimized using the ADAM algorithm over 1,500 iterations. 2,000 iteration. Okay. Here is the visual representation of our experiment data. Okay, let's look at the conversion of the model on the dataset, which is our animation in the screen. As you can see from the plotted animation, our quantum model consistently exhibit the facet conversion rate. What's more, it show remarkably minimal fluctuation throughout the training process, indicating a higher degree of stability compared to classical counterparts. We shall wait until this demonstration is complete. So yeah, here we are. These results strongly suggest that quantum model can achieve superior performance in minimizing the loss function for the dataset, showcasing the robustness in learning and inferring physics and finding parameters to PDE. The larger classical model did converge very well, but with less stability. The smaller classical didn't converge at all. They struggle within our experimental limits. Beyond just minimizing the loss, we also evaluate the model's ability to recover the unknown parameters. The sample result for the mu equal to 4 dataset, as you can see from this graph, both on the quantum model and the large classical model were very successful in estimating the missing parameter mu equal to 4. However, the significant observation here is a quantum model can have smoother conversion during this recovery process, as you can see in the orange line. No, the green line. In a stark contrast, the smaller physical didn't converge at all, producing the incorrect output and highlighting the limitation in learning capacity for this specific problem. So what do our results imply? We found several key advantages of our physics-informed machine learning. Firstly, the quantum model consistently demonstrates the faster conversion. Secondly, it shows better performance, achieving lower loss value and more accurate parameters recovery compared to classical counterparts. This benefit can stem from the principle of quantum mechanics through the parameterized circuit, which are inherently well suited to approximate the dynamic of a PDE system, in this case the physical system. Crucially, the wave-like probability distribution inherited in this model can be a better fit to infer certain type of problem in physics and PDEs directly from unprocessed data point. An implication of this research is the potential advantage in predictive modeling. Our methodology suggests enhanced capability in inferring solution to in here physical problems based on their governing laws. which contribute to scientific discovery and revolutionize computational PDE and physics. So in conclusion, quantum computing offer a genuinely transformative potential for solving PDE, particularly for the most challenging high-dimensional and quantum-related problem. My work and that of many others demonstrate that hybrid quantum classical approach provide the immediate and practical pathway to make use of today's noisy quantum computing devices. This algorithm can act as a powerful accelerator and optimizer for the existing classical methods, enhancing their capabilities. And that is the end of my presentation. Thank you for your attention.
Thank you very much for your presentation. Do you have any questions? So your presentation is too difficult for me, so I have no question. So Professor, do you have any questions?
Yeah, no, I also don't have any questions, but it was a very interesting topic. Just one quick question. What challenges did you face while applying quantum approach?
Right, let's go back to this particular slide. So to apply this formulation to our cost function, we actually have many of the constraints. Firstly, the data. The data in the real world scenario is not very clean like this. In here, as I artificially manually generated the data is very precise, but in the real world, there's no such precision. We have measurement error all the time, and the data we collected is can be wrong or flawed. For example, in here is a harmonic oscillation. As you pull down a string and record its movement. For example, just for the sake of scenario, you pull too hard or too strong, or let's say the string is flawed, and you have no idea how to assume the problem, and that would be the challenge yet to be solved. Another one is to formulate the quantum circuit. For example, in here, um, today's quantum computer are not that powerful of a machine. It's for my experience, I have to simulate the quantum circuit myself, given a Python package. But the majority of quantum devices are not at all. They often be noisy, and not many qubits can be used at once. Otherwise, it will just collapse into garbage. In here, I have the setup of 2 qubits, taking almost 30 hours to have this very nice animation prepared for you guys. On a quantum computer in the future, it might be very faster compared to that of training on a PyTorch and a GPU. But for this time, not at all. Don't give it into the hype if any other researcher just tell you so.
Okay. Okay, that's it. Thank you.
Thank you for attention.
Thank you, dear
So how
presenter,
do
for your presentation. And now I'm going to conclude this session. I sincerely thank our author for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during 9th version of all and all the previous 8th version of this conference. We will be happy to have you in a 10th version of 2026. All the presenter would be getting their digital certificates email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of WS4. I also thank our chair of this session, for chairing this session. Thank you so much, sir, and thank you so much, ma'am.
Thank you, everyone.
Thank you, Richa. Thank you, Professor.
And here is a token of appreciation from behalf of the whole team.
Thank you.
Thank you.
And I kindly request to all turn on the camera to quick snapshot to making this virtual conference more memorable. Thank you so much, everyone. Thank you so much, ma'am. Thank you so much, sir.
Thank you, everyone. Have a great day.
Thank you
Yeah,
so
yeah.
much.
Bye.
Thank you.
All the best for your research. Bye bye.
Thank you.